In this recording, I am going to introduce the topic of differentiation. So, differentiation is all about gradients. Let's start with looking at gradients that you may already be familiar with. So, the gradient of a straight line. We've got a linear graph here. How would you find the gradient? Well, the gradient represents how steep the straight line is. So for every 1 we go across, we're going 2 up. 2 divided by 1 is 2. The gradient, which often we refer to as n, is 2. So the gradient is the change in y over the change in x. It's how much y is changing with respect to x. So if the straight line was not as steep, the y would not be changing as much. For every 1 you go across, you might just go 1 up. In this example, for every 1 we go across, we go 2 up. So it's got a steeper gradient. So again, gradients represent a rate of change. So we've got a graph showing a bathtub being topped up. We have the depth on the y-axis and the time in minutes on the x-axis. The gradient on a straight line is constant. The gradient represents the change in y over the change in x, so the rate of change. So we could say here, 5 centimetres, that the depth of the bathtub is increasing by 5 centimetres per minute. That is the rate of change. Now it's a little bit different when we look at a curve. Why is this different? Well, the gradient is changing. As the time increases, you can see that the gradient is increasing here. So how do we find the gradient of a curve? Well, what we could do is draw a tangent. The graph below shows the curve of y equals x squared. Find the gradient at x equals 1. I could put a little mark here when x is 1, and I could draw a tangent to the curve at this point. Because at this point here, the gradient is the same on the curve as it is for that straight line. Okay, now I can find my gradient here by looking at the change in y over the change in x. Change in x is 1, change in y is 2, so the gradient here is 2. Okay, so find the gradient when x is minus 2. So again, I'm going to use this method of drawing a tangent. So as you can see here, the gradient will be negative because we've got a slope downhill, and it is steeper than when x is 1 as well. So let's draw my tangent. So change in x is 1, change in y is 1, 2, 3, 4, 4.6 maybe. 4.6 divided by 1, and it's negative, so the gradient is minus 4.6. Okay, so what are you thinking about this method to find the gradient? Well, it's not very accurate, is it? So your tangents, people may draw them slightly differently, can't get it exactly correct. So it would be useful to have a different method of finding the gradient. Now, I know this different method. So let's just have a look here. So here's a curve, and we've got the graph y equals x squared. I know that when x is 1, at this point here, I know the gradient is 2. When x is 2, I'm going to tell you the gradient 4. When x is 3, the gradient 6. Have a guess. What do you think the gradient bit would be when x is 4? Hopefully you've decided it was 8. So here for this particular graph, the gradient is double the x value. So if the x value is x, the gradient would be 2x. 2x is the formula I'm using to find the gradient. Now, this symbol here means change in y over change in x. So it's the formula that finds us the gradient. So for a graph y equals x squared, we could just see that the gradient function, gradient formula would be 2x. For y equals 3x, I'm going to tell you that the gradient formula would be 3x squared. For y equals x to the power 4, it'd be 4x cubed. Have a little guess. What do you think for x to the power 5? It would be 5x to the power 4, 6x to the power 5. Okay, have you noticed what I'm doing to find the gradient? Well, I'm multiplying by the power and I'm taking 1 off the power. So I have differentiated this function. So differentiation is what we do to find a formula for the gradient. So the formula for the gradient is dy by dx, as I've said, means change in y over change in x. And we multiply by the power. So if our function is x to the power n, we multiply by the power and take 1 off the power. Okay, I'm just going to discuss how to differentiate the following functions. So for the first one, x to the power 6 plus 2. Okay, I might just go back to my graph, y equals x squared. Now, we discovered the gradient function here was 2x. Well, the gradient, the power is 2, isn't it? If we times by the power and take 1 off the power, we do get 2x to the power 1. Okay, now let's just have a think about this. Here's our curve. I'm just going to try and trace over this curve as best I can. Okay, well, let's just take the first bit of this curve. If I move this curve, and then this became the graph y equals x squared plus 5, would the gradient change? No, it wouldn't. The steepness of the curve stays the same. So if we differentiated y equals x squared, we discovered we have y is 2x. If we differentiate y equals x squared plus 5, actually, to differentiate that, as we've discussed, the gradient would stay the same. It would just be 2x. So the gradient function would be 2x. That's our formula to find the gradient. So if you have a constant term, you can just ignore that when differentiating. Okay, so our function y equals x to the power 6 plus 2, dy by dx would be 6x5 to the power 5, because we've multiplied by the power, taken 1 off the power, and that would be it. We can ignore that constant term. So what about 2? The power is 3 here, so we multiply by the power. 3 times 2 is 6. Take 1 off the power, squared, or constant disappears. Okay, so y equals x. So what would, if you had to assign a power to y is equal to x, it'd be y equals x to the power 1, right? If I multiplied by the power and took 1 off the power, x to the power 0 is 1, so we just have 1. So that would differentiate to give us 1. And actually that makes sense, doesn't it? Because what would the gradient of that graph be? Well, it's a linear function, isn't it? Y equals mx plus c. We've got 1x. The gradient would be 1. So similarly, let's have a look at y equals 5x. Again, if we had to assign a power, x to the power 1, times by the power, take 1 off the power. Oops, sorry, that should have said that here. Would be 1 times 5 is 5, x to the power 0, x to the power 0 is 1, so we would have got 5 times 1, which is 5. Again, we know, don't we, for that linear graph, the gradient's 5. So when you have a linear function, So, or a x to the power 1 term, the x just disappears. So let's just have another example over here. Let's do this part B. So if y was equal to 3x, dy by dx would equal 3. Okay, what about y equals 3? Let's just have a little think about a graph for this. What would it look like? We sort of discussed this here when we discussed ignoring this constant term. So y equals 3 would be a horizontal line going through 3. Well, what's the gradient of that horizontal line? It is 0, isn't it? So dy by dx would be 0. And for number 5 here, if we differentiated this function, we would get 3x squared minus 8x plus 2. Okay, so have a go at these 5 questions yourself maybe, and put me on pause, unpause when you're finished. Okay, question 1, power's 2, multiplied by the power, take 1 off the power, 14x. 3 times 3 is 9, take 1 off the power. This is x to the power 1, so don't forget the gradient, the x would just disappear here. 3 times 8 is 24, x squared plus 1, because it's 1x. And here we would have 7x to the power 6 minus 18x to the power 5. Here you would have had to expand these brackets first, which gives you x squared plus 4x plus 2x plus 8, which simplifies to x squared plus 6x plus 8. If I differentiate, we get 2x plus 6. Okay, maybe have another go at these questions. Again, put me on pause, unpause when you're finished. This first one would be 0, 7, 28x cubed minus 9, 10x, 3, nope, 24x squared. Expanded and simplified would give you x squared minus 12x plus 36. Don't forget here to write as double brackets first and then expand, which would give us 2x minus 12. This one we will come back to in a minute. Let's just have a look at some other questions first. Okay, let's just talk through these examples first. Y equals minus x squared, multiply by the power, take 1 off the power, minus 1 times 2 is minus 2, x to the, take 1 off this power, we just get x to the power 1. We don't really need that there. Maybe have a go at this one yourself. So this one we'd get minus x, no we wouldn't, we'd have minus 3x to the 2. Okay, what about this one? Our power is minus 1, so if we times by the power we get minus 1x. Take 1 off the power would be to the power minus 2. Have a go at these next 3 yourself maybe. So this one would be minus 2x to the minus 3, minus 3x to the minus 4, minus 4x to the minus 5. What about this one here? Well, we can't differentiate until we have it expressed as x to the power n. How else can you write y equals 1 over x? We can write that as x to the minus 1. So this is looking at your negative indices topic. If you remember, y equals x to the minus 2 would be the same as y equals 1 over x squared. Y equals x to the minus 3 would be y equals 1 over x cubed. Anyway, now we've written that in this form, multiply by the power, take 1 off the power, minus x to the minus 2. And then for question 8, again, let's rewrite it as x to the power n, which would be x to the minus 2, multiply by the power, take 1 off the power. There we go. Let's go back to this one now, maybe. So this would be 3x to the minus 3, rewritten as x to the power n, because you've got here 3 times 1 over x cubed. Now we need to differentiate. Times by the power, take 1 off the power. Minus 3 times 3 is minus 9, x to the minus 4. Okay, let's look at some fractional powers here. First of all, if y is equal to x to the power half, well, it's written in the form x to the power n, that's fine. dy by dx times by the power, take 1 off the power, half x to the power minus half. Y equals root x is not written in the form y equals x to the power n. So what we would do to that is write it as y equals x to the power half, and it would just differentiate same as this. X to the power a third times by the power, take 1 off the power. So y equals cube root of x will be written as y equals x to the power a third times by the power, take 1 off the power, a third, x to the minus 2 over 3.